Okay, we're ready.
Okay. I want to thank everybody for joining us. This is Chuck Davenport with Forerunner Technologies, and today we're going to do a presentation on the SV9500 platform with also quite a bit of information on the UG50 and that potential configurations out there. We have done these webinars for about the past year and a half. This is kind of a refresher, but we felt it to be very important because we are getting quite a few questions and a lot of interest on the UG50 application and solution and all the different types of configurations and migrations on that product. So we felt that everybody needs to kind of understand the applications and all the strengths of going to that platform. We are going to cover quite a bit of information here. We've got Howard Thurlow and Mark Masaryk, both from NEC. Howard will be doing most of the presentation, but Mark is definitely there to help out whenever needed. And because there's quite a bit of information in here, we wanted to leave time for any questions that might come about. And for that reason, we're going to kind of forego the Forerunner part of it and just go straight into the presentation. If you have any questions, need further information once we're done, I'll be more than happy to go, help out in any way. Just throw an email at me or give me a phone call. If you don't have my contact information, just send me an IM here, and I will certainly respond back with that information. So with that, I want to hand it over to Howard Thurlow of NEC.
Great. Thank you, Chuck. Thank you, Stephen. And good afternoon, everybody. We're going to be taking a look at the SV9500 platform today, but only a couple of specific subjects. So this is not an all-encompassing readout. And I'm joined today by Mark Masaryk, who is our Senior Product Manager for the SV9500 platform. So as I mentioned, we're really going to focus today on the architectural highlights of the 9500. Traditionally in the history of PBX technology, when a manufacturer comes out with a new release or a new revision, it's typically all about something like a faster CPU or 50 new features that have been added to the PBX. But the 9500 really was quite a departure for us compared to that traditional approach, because we really focused on how the product can be deployed in today's modern IP environment. And so we created some new deployment models for the core of the system, which we'll be talking about today. And we also introduced the UG50 Remote Gateway, which is an IP-connected configurable gateway shelf that can be placed at a remote site. So we'll look at both the core and the remote approaches today, and then we'll kind of put it together at the end with some sample designs to give you an idea of what this looks like in practice. So before we start looking at the product itself, I wanted to just spend a moment to talk about 5 nines. In our business, the 5 nines is sort of a given. It's the idea that the system will have very good uptime. It's designed to do that. But what does it actually mean in terms of downtime? So here are just some examples for you. Starting here at the bottom, let's say for a moment that you were going to implement some application on a standalone server or a blade server with RAID disk configuration. And that type of environment can typically be expected to provide 99.5% uptime, which, if you do the math over the course of a year, is 43 hours of downtime, or roughly 2 days, obviously spread across the entire year. So if you're running a business and you're running an application on that type of technology, the application you're running should be expected to fail multiple times during the year. And, you know, you need to be prepared for that. So the application cannot be certainly business critical in that situation. But what most people are doing these days is they're using virtualization technologies such as VMware and Microsoft Hyper-V as a way to implement multiple applications on a single physical server. And those technologies come with a high availability feature set that allows them to achieve 3 nines or 99.9% uptime. So if you're running your application on 3 nines, your expectation is about 8 hours per year of downtime, which again, for a business, if it's a business critical application, there's obviously going to be impact to the organization when that happens. When we look at 5 nines though, 99.999% uptime, if we do the math on that one, we actually are going to be expecting about 5 minutes downtime per year, which, you know, we're looking at a situation where we maybe have 1 event. And so, you know, this is what we expect from a phone system. It's always been this way, and it always will be that way. And in order to get that type of availability out of a server-type technology, you really have to have more than just RAID or VMware high availability. You have to have something else, and we'll talk about that here in just a minute. So what I want to show you now is the fact that there are 3 ways to build the SV9500 core. So we're going to look at what those are. And we're going to look a little differently this time. We're actually going to start out by looking at the system software. The system software is what provides all of the over 800 service features of the SV9500. It's been built up over many years of experience working with our customers around the world. And that software is the same regardless of how you deploy the SV9500 core. So we start with the software. And if we install that software onto the SV9500 appliance, which is shown here on the left, this is the front end of the PBX. This is the traditional front end. If you have an SV8500 today, it's a very similar hardware setup. It's a little bit more current than what you may have in terms of CPU and so forth, but it is essentially the front end of the PBX. And to that, we can add any number of phones, and we call that the appliance model at NEC. So when we refer to the SV9500 appliance model, what we're saying is that we're using the SV9500 appliance as the front end. And you might consider this to be the traditional approach. But another approach that we can take is to use what's known as a fault-tolerant server manufactured by NEC. And we can preload that server with VMware, Hyper-V as required, including all of the operating system and all of the applications for the SV9500 itself, as well as the applications. So UM8700 voicemail, for example, or unified communications tools can all be loaded as applications in this environment. So when we take the NEC fault-tolerant server and we add some number of phones to that configuration, we call that the prepackaged model, because we are prepackaging all of the software onto our server and delivering it as essentially an alternative to the appliance. And then the third option would be for our customers that already have a sophisticated data center environment that's using virtualization technology. All we need to do is install our software into that environment using the correct virtual machine configurations, and then add some phones to that configuration. And we call that the software-only model, because we're not delivering an appliance and we're not delivering any servers. We're simply delivering the system software into the environment and building the system that way. So these are the 3 key approaches that we talk about: the appliance model, the prepackaged model, and the software-only model. In terms of the SV9500 appliance itself, it is the central control for the system. It contains the main processing unit, and it can be configured with full redundancy, which means redundant power, redundant CPUs, and redundant bus. And that extends throughout the entire system architecture. This appliance delivers 5 nines of uptime, as we always have, and is the centralized call control for the entire network. The alternative, which is to use the prepackaged model, utilizes NEC's R320 fault-tolerant server. Now, you would probably go with the prepackaged approach if you had a relatively small percentage of TDM endpoints, but a very high percentage of IP. So you might consider the prepackaged model for a IP phone deployment that has a small number of gateways, but it's primarily IP. And what we do here with the fault-tolerant servers, we actually are able to deliver 5 nines within the box. And the way we do that is via the fact that the R320 is actually 2 blade servers in 1 chassis. And these 2 blade servers, as you'll see, operate in tandem to provide 5 nines. So this is a block diagram of a typical server. In this case, you can see on the right-hand side, we have 2 CPUs, 2 memory banks that are interconnected. We have an input-output handler and some input-output interfaces, things like disk interfaces and so on. That's the traditional arrangement for a traditional server. What we do with the fault-tolerant server is we take that same architecture and we add to it something called the Gemini engine, which is shown in dark blue here in the center. The Gemini engine is proprietary NEC technology, secret sauce, if you will. And its purpose in life is to actually watchdog the system and talk to its counterpart on the other side. So there's actually going to be a second system with an identical hardware configuration. And these 2 Gemini engines are able to talk to one another and observe the behavior of the system and create an environment where the system can automatically continue to operate under the event of a failure. In fact, what actually happens is both servers are running the same software at the same time. They're executing the same exact instruction on the same clock cycle together for every single instruction that's happening throughout the system. The output and the input for those activities are all latched in through the Gemini engine. So the Gemini engine gets to decide which server is actually the active, healthy server. And the idea is that with both servers operating in this manner, if I was to switch off one of the servers, the next instruction that's to be executed would be executed on the other server, as it always is, and we would just latch through the input-output for that server. So we can actually switch over and switch back the server internally with 0 loss of activity. Every instruction will continue to be executed. So let's go back to the appliance model now. Let's consider the idea where we have an SV9500 that we're going to use the appliance model probably because we have a large percentage of TDM endpoints. A good example of this might be a hospital with a large number of patient room analog phones, or even a hotel also with a large number of patient room analog phones. So we're going to need some hardware to drive those TDM interfaces, and to do that we use the 7U gateway chassis. The 7U gateway chassis is new with the SV9500. The older gateway chassis were slightly larger. They were 8U. And this chassis also has a full complement of 18 universal card slots. And we can stack these gateway chassis up within the system, and these are all rack-mounted units. And when we do that, we end up with something that looks like this. This is just a diagram of a simple rack where we have the 9500 appliance mounted in the bottom of the rack, and then the time switch equipment in between it and the gateway chassis. Here we're showing 2 of them in a rack. So we build the system up by adding these gateway chassis and all the necessary cards. We can fit 1,536 ports per rack, and that's inclusive of TDM and IP, and we can mix and match that. And of course, we can go well beyond 1,536 ports. I'm just showing you the how to build it here. Now, if you had the same project, but you were really dealing with a lot of IP phones, let's say you had 1,000 IP phones and a few PRIs or something like that in your configuration, then you would really be building what we would call a pure IP system. And to do that, you could choose to use either the appliance as shown on the left, or you could choose to use the fault-tolerant server as shown on the right. In either case, we can go up to 4,000 IP ports per system, and we can also network multiple systems together to provide a 192,000 port maximum network size. Another capability that's offered with the SV9500 is what we call geo-redundancy. The idea here is that I can have two identically prepared data centers that contain all of the system software applications, and either one of these two data centers is able to hold up the entire network. So this is truly a disaster recovery model, and this is a model that's now supported by the SV9500. And you can see on the bottom here, we're showing just some generic images of some IP phones and gateways. We'll take a look at that later, but that's really the UG50 concept that we're showing here. So, Chuck, I'm going to pause here and see if, actually, we're going to take our questions at the end. So we're going to move on now to the UG50. If you have any questions on the core, please jot them down, and we'll get to those at the end. So the UG50, we're going to cover these areas today. We'll take an overview of the system, kind of show you around a little bit. Then we'll take a look at connectivity and interfaces. So, you know, what type of interfaces are supported by this system and how do we plug it into the network? We'll also then take a look at the survivability option, which is available with the UG50. Then we'll talk about some of the advantages that the UG50 has over other approaches for remote service. And then we'll take a look at service conditions for the product itself. So this is a photograph of the UG50. It's a 19-inch rack mount multi-slot gateway device. And what we're going to do is we're going to connect this onto the LAN-WAN infrastructure. So it's IP right into this box. And then we're going to configure the individual slots with the appropriate cards that this particular site needs, whether they be digital phones, analog stations, trunks, or what have you. We're going to custom build this box to fit the environment that it's being placed in. One of the great things about the UG50 is that we can support local trunks. So, for example, we can deliver 911 calls from a remote site out on local trunks without ever having to go to the host, which is terrific because if we ever end up in a standalone condition on this one and we have the survivability option installed, we can actually continue to process outbound calls. So we can make those 911 calls in the event of a failure. The UG50 has a maximum capacity of 96 ports, but these are actually stackable. And I'm using the word stackable in quotes here. What I mean by that is that we can put multiple units at a physical site. They are not interconnected to one another like Cisco stackable switches or something like that. They are separate units, but because they're all reporting back to the 9500, they're essentially making up that remote site. And we can make it survivable as well. So here's what the front of the UG50 really looks like in terms of what we can do with it. The first thing that we want to tell you is that it is an AC powered unit. So there is AC power connector on the back of the unit. And we also need a single 10100 Ethernet connection. That connection is made on the front of the CPU. The CPU is shown on the bottom of the screen here. You'll see there's a VoIP port. That's where we connect the UG50 to the network. We also have this second Ethernet port. That's a maintenance port. So we're able to put that CPU into the first slot as shown here. There are 6 card slots on the UG50, and we'll number them slots 1 through 6 for the purpose of this discussion. So slot number 1, will always be the CPU, and the remaining 5 slots can be line cards or trunk cards. In terms of what's available for line and trunk cards, it's a pretty straightforward list. We support digital D-term phones using our digital cards, 8 and 16 ports. We also support analog extensions using 8-port analog cards with extender daughter boards as well. We support analog trunks for central office trunks or 1FB lines using the GCD4 card. And we also have support for PRI interfaces. And we can mix and match these cards within the UG50 to provide a custom fit for each remote site. For those of you that have been around the 8500 and 9500 for a while, you're probably asking yourself, where are the pad cards? The answer is the UG50 has built-in internal pad cards already. The pad card is a packet assembler, disassembler, and its job is to sit in between the IP side of the network and the TDM side of the network and basically translate the voice from a packetized format into a non-packetized format. And of course, because we are actually running on a 9500, when we put station and trunk ports on the UG50, we do have to equip them with licenses. So for example, if you put a analog phone on the UG50, you would need a basic user license for that phone. Survivability is an option with the UG50, and it's provided by a card known as the Survivable Remote Node card, or the SR Node card. The SR Node card is installed into the last card slot, or slot 6, and it can provide survivability for up to 300 ports. Now, these 300 ports can be analog ports, digital ports. They can be IP phones that are located at the remote site, trunk cards. So anything that's served by the UG50 can be made survivable. And in fact, the SR node can support up to 300 ports, which is well beyond the capacity of a single UG50. So really what we're able to do is we can span multiple UG50 units and provide survivability to them. And we can identify at the port level how we want to do the survivability. In other words, is this station going to survive or not during a failure? In terms of the behavior of the system when we are in standalone mode, we'll look at it in terms of, first off, outbound traffic. So any outbound traffic that was possible from the UG50 before it went into standalone, that traffic can still be processed. However, we have to take a look at what trunks are available in normal operation and in standalone mode to see what's going to happen. Most remote locations, if they have a central office nearby, will have central office trunks that go directly from the remote site to the nearest central office for handling of 911 calls. So most sites will have some analog trunks, but we can also provision PRIs at the remote sites. And all we're going to have in standalone mode is whatever trunks are available to us at the remote site. So for example, we may decide that we don't care about any outgoing calls when we're in standalone mode except for 911, and we can provision the system that way. We could also say that certain types of calls besides 911 could also be delivered onto those local trunks, but maybe not all calls. In terms of inbound calls to the site, obviously if we've lost our WAN connection, there's really no way to get a call from the 9500 core down to that remote site. But if you're using a telco provider who provides a routing portal, which is the ability for you to actually change routing in the network, you can actually redirect calls to go a different route. And you could actually route a group of numbers to go out to the public network and come in the back door, if you will, of the UG50, perhaps on a PRI. So there's a lot of different things to consider here. We give you the tools, but it's important to lay out how you actually want the system to operate. That kind of tells you how it should be configured. The other thing that's fairly obvious here is we don't have access to core applications when we're in standalone mode. So if we look at voicemail as an example, when calls are directed at users on the UG50, if we can't get there, those calls are going to get a voicemail anyway. And let's assume for a moment we have a UM8700 voicemail at the core. It's going to go ahead and take that call, record it. But then the users won't know about it until they plug in the network again and the system comes back up. At that point, the message waiting lamp will light on the phone and they can go in and retrieve their messages. If they also had unified messaging, they would also still receive their messages in their Outlook inbox, for example, during the system outage. So that's how voicemail would work. In the case of ACD, for example, obviously if you have remote agents that are hanging off of a UG50, they're not going to be accessible during an outage. You could use backdoor trunks to get them brought into the fold, but those phones, when they're in standalone mode, they're just phones. They can operate like a hunt group, but they can't operate like a true ACD because that control is in the core. So just realize that applications that exist at the core won't be available, and you need to consider how the system should function in the event of that failure. So why might you choose the UG50? Well, let's consider what I'm going to call the old way. If we had a need to add 5 remotes to our system today without the UG50, we would probably go get 5 SV9300s. At that point, we've now procured 5 PBXs. We have to manage and maintain them over their life cycle. We also have to create a potentially complicated inter-system dialing plan, maybe using our CCIS technology. We have to integrate all of the applications from those sites. And really, just to do simple numbering additions, we may have to touch every system in the network. So having multiple PBXs in a network, generally speaking, means more work forever. And that's what we're trying to fix here. Another thing to be aware of is that the feature key and button operation of our phones is slightly different on the 9300 than the 9500. So if you had both systems in your network and people traveled from one site to another, when they pick up a phone, the features and the buttons will work a little different. And in an ideal world, we would not have that difference. So we would consider these things to be sort of bad, right? The things that are bad about this are maintenance, management, dialing plan, feature operation, quite a few things that are not perfect. But with the UG50, what I'm going to call the new way, we can establish 5 remotes, and they will still be part of the SV9500, and there will be a single system image for the entire network. So this means that we have a single system to manage and maintain. It's a simplified approach. All of the applications that are installed at the core are available to all users at all locations, including the UG50s. And of course, we have a single dialing plan now that's internal to the PBX. We're not doing multiple PBX routing here. And because everybody's now a 9500 user, those phones are going to work the same regardless of where they are in the network. So we think that taken as the sum total, the new way is better than the old way. And there may be circumstances where the 9300 makes more sense. We'll talk about a couple of those, but for the most part, we should be looking at this in terms of old way and new way. The other great feature that NEC has made available is the fact that we can convert the SV8300 chassis and cards into a UG50, and that's what we're showing here. On the left-hand side, we have 3 shelves of an SV8300 that contains a mixture of digital, analog cards, and trunk cards. And what we've done is converted that to 4 UG50s on the right. And the reason we do that is because each UG50 needs that green card that we're showing, the CPU. So the CPU is going to occupy 1 slot. And that wasn't the case in the 8300 on the left. So we're going to need more card slots for the CPUs and also potentially another card slot in position 6 for the SR node card. So typically when we convert 8300 to UG50, we end up with a little more real estate to accommodate those new cards and also to allow for growth. So if you're interested in converting an 8300 to a UG50, we actually have conversion kits available for that. And then the survivable remote node is just an option that you can order if you want it. I should also mention on the survivable remote node that the card itself can support up to 300 ports, but those are licensed ports. So the SR node starts with the 50 ports, comes with the card, and then you have to add additional ports to get you up to 300 if you would like to do that. In terms of the service conditions, this is NEC language for, things that you can do and cannot do with the product. The UG50 supports most of the 9500 capabilities, but there are some exceptions. The exceptions are documented in the UG50 Peripheral Equipment Description document, the PED. But what I've done here is just extract some of the key limitations of the product here. First off, we do not support Desilis digital phones on the UG50. So Desilis phone is one that does not have the paper strip label under the buttons. It actually delivers the button content digitally to the display of the phone. And the UG50 cards just aren't able to do that, so that's why we can't support those phones. However, if you have a Desilis IP phone, it's no problem because the IP phone is getting its display information through the network from the 9500 core rather than the line card. Another thing that doesn't work is the Plantronics headsets with the electronic hook switch. This is the idea that we have an electronic hook switch that essentially takes the handset off hook and delivers the voice over to the headset. That integration is something that's not supported on the UG50, as is also the Bluetooth adapter not supported. So if you have a Bluetooth adapter for the phone, it will not work on the UG50. So those are phone type restrictions on the UG50, but we also have some trunk limitations, and it's really based on the type of cards we can put into the UG50. So we can put central office trunk cards and PRI cards into the UG50 for your more traditional T1 and 1FB type circuits. But for example, if you wanted to do E&M trunks or line side T1 trunks, those in the PBX require a special type of card that's not been made available for the UG50. So if you had some circuits like that at that remote location, we have to come up with some sort of a, an FX arrangement, or possibly decide to, go back to the 9300 in this case, if you had any of those interfaces that you needed at the site. Also, voice encryption is not supported on the UG50. So voice encryption is typically used more in a government environment where we're going to encrypt the voice so it can't be stolen by anyone and listened to. And if we need to have that, then that's something that is not available on the UG50. The UG50 is also not available with any real form of redundancy, so we cannot put redundant power or redundant CPUs or redundant bus into the system. It's a simplex design. But we recommend, of course, external batteries or UPS to keep the power up on the unit. We also would recommend putting that UPS on the Ethernet switch that the system is connected to, so the whole network is up. But if you're really looking for greater redundancy in terms of the actual, for example, having a backup CPU or something like that, you may consider the SV9300 as a better choice. So we've talked about 3 different ways to deploy the core of the SV9500, and we've also talked about how to use the UG50 as a remote survivable unit. So what happens if we put those 2 together? These are some sample designs from real customers, just to give you an idea of what this looks like in practice. So here's just a generic customer approach. This customer is actually a city, and they have various departments throughout the city, different buildings everywhere. They have 2 data centers, and what they've considered doing is using the virtualized or prepackaged model, because they're going to be deploying all new IP phones. And they're going to be using PRIs at the core. These UG50 PRIs shown on top could also be actually SIP trunks as well, so we support both. And then down here on the bottom, we are showing the UG50 and IP phones as a package. That would basically be a remote location. And so what these folks have chosen to do is kind of divide the sites roughly 50-50 in the environment, but just be aware that if the entire data center 0 is to just go dark completely, all of the services down here, all the phones, all the trunks will all be running off of data center 1. So we call this the dual data center approach. This uses both the geo-redundancy capability and the UG50. Here's another one. This is a university campus, very similar design. This particular customer has also the appliance model 9500 still in their network, so we can mix and match the appliance model and the fault-tolerant prepackaged model as we're showing here. Here's an example of a nationwide call center. This is an organization that is in California, but rapidly growing nationwide. They have the SV9500. They have quite a few 8300s and 9300s spread around. And so what we've done here is taken the multi-data center approach. We actually have 5 data centers around the country, each of them with the fault-tolerant arrangement for the 9500 and the applications. And now we have such great coverage that we're able to just build remote, what we call remote agent pools, pretty much anywhere for this customer to support their dynamic business. And the last one here, this is an airline. This is a reference architecture for an airline that's based here in the United States. Obviously, they have facilities all over the place, looking at providing service based on a dual data center approach, East Coast and West Coast. And each airport is a cluster of UG50 equipment with IP phones, all in a large centralized geo-redundant network. And with that, Chuck, I guess we can pause here and take a few questions.
Absolutely. Any questions, anyone?
Am I live?
You're live.
Am I the only attendee here? That's all I see on the screen.
Well, no, that's all everybody sees on their screen.
Oh, I don't see all the other folks?
Yeah, no, it's by design.
It's all about you.
Okay. Well, listen, I sent my contact information out. If anybody has any questions or things come up and you need further information, please feel free to reach out to me. And I may not know the answer, but I know people who do know the answer. So with that, I'll go ahead and Stephen, if you can stop the recording, we'll go ahead and finish up here. And I appreciate everybody taking the time to sit in on the webinar.
Yeah, thank you very much. I'm going to go ahead and stop the recording, but for everybody, you know, we record these every month and we put on we now have a YouTube channel. So all of these sessions for the last year and a half are on our YouTube channel. So if you can't find that, let us know. Chuck and I can send that to you, but we'll put this one up in the next couple of days. All right? Happy holidays, everybody. Merry Christmas, all that.
Thank you very much.
Bye, everybody.
Bye.